Okay. The two very important announcements have been posted. First of all, the final exam is scheduled in that way, which is I think it's the second week of December. So you can choose one of those days. December 14, 15, and 16.
Does this mean we're not meeting for class those 3 days?
Yeah, we do not have a meeting. Those 3 days, not only for this 520 but 560. Whoever is taking the 560, you need to plan the exact same day. So those who are taking 2 classes from me needs to take 2 time slots out of the 3.
Is your other scheduled the same days?
Yeah, you're right. Other classes for the same days, right? But you don't need to take 2 exam at the same day. You have to plan for 2 different days, right?
It's a 3-hour window I got at the same
Yeah.
time. I'm not going to be jumping back and forth with quizzes.
Just 2 tabs open and you're doing 2 exams at once.
Yeah, for example, you can you can take say this class Wednesday and another class maybe Friday or Thursday, whichever convenient to you. The easiest way is that the day that you come here for on-site class will be the time that you can take. For example, this 520 on Wednesday evening, then you better take it Wednesday. For those who do not have any specific, cannot make it, then take it another day. Okay, that is the final exam. Final exam will cover, in general, from beginning to the end, everything.
It's going to be coding on the paper.
Coding? Yeah, Chris said no. Somebody said no.
Can you give us an idea of what the format would be?
Short answer. Short answer.
Okay.
Yeah.
How many questions approximately?
Approximately 10.
Okay.
Yeah.
Thank you.
About 10.
On-site or
Usually, this is on online. Yeah, even on-site students can take online. But if you come here, then you can take it on-site, but no class. Okay.
He's got any questions. Is it 10 one-part questions or is it 10 8-part questions?
That's a very good question. How did you know that?
So, that means it's going to be multi-part questions? Is that 10 questions then?
Do we get partial credit though?
That's why it's 10 questions. Multiple answers.
Do we get partial credit though if we get part of it right and part of it wrong?
Let me tell you. Not more than 10 big questions. I would say 5 to 7 big questions. Each question may have 3 to 5 small questions. Reason I'm asking you 3 to 5 small questions is that those are the steps. I do not want you to have a big surprise. Usually when I give you small questions, those are the steps that you can reach the final goal. Actually, if you are asked at some of the exams or interviews, they may ask you the final questions. If there are more than one small questions, those are the steps. Those are the basic concepts that you have to understand in order to reach the final result. That is the points, the idea that I make small questions.
We're not making trees, right? Please no trees. Because homework 5 was not short.
Oh, decision tree?
That took me from 2 p.m. until 7 p.m. to work on. and get it done using Visio.
By
I did it in
calculator
software.
or?
I did it in software. I use Visio, and it took me that.
Oh, great.
The
So that helps you.
entire tree.
Right. To your life, only one overnight calculation will be a good asset of yours.
Yeah, no, of course.
For this homework, when you first posted the homework, did you put the link for the database, for the car database? Because
Thing is this, you need to calculate information gain
like
for
here,
each column,
yeah.
and then pick a column which has the
Yeah,
biggest
that's it.
information gain, which is the root of the tree. And then that column might have
Other branch.
the values, right? So you can categorize those values.
Yeah.
Depending upon the size of values. For example, if it is arbitrarily numeric data, then you probably need to categorize.
Yeah. My question is when you posted.
And then it's a sub branch. Say this, for example, age. Presumably, age is or income. Okay, income. Income is the column that you chose for the first node of your decision tree. Then income is vary, right? Somebody has, hey, William. So income maybe somebody is 125, some other guy is 263. All different individual values. Of course, with each values, you do not want to branch out. In that case, you can group them. For example, low income, medium income, and high income. Upon your definition, okay, you can define, and then as you branch out, then you have a small set of table, right? If it is all low income, then of course that's part of the given data. Then you need to apply the same process from there. Again and again until no further branching out needed or table already branched out completely. Right. Exactly.
On the table. My question is, when you put the homework, the first day, you didn't put the link. I didn't see the link for the car.
Right, I forgot.
Seriously? Yeah, you're sure, right?
Yeah, somebody. I think you emailed me, all right? I did
it with the age. I did the table with the age, and I sent you the homework the same day. And when I sent you the homework the same day, after a week, I was just looking to see if you graded, and then I see that you added the link for another database.
Yeah.
It's at 2 hours before the deadline. And I did it in 2 hours before the deadline and finished it, but I wasn't able to send it.
Okay. Make it simple. Okay.
I sent it to you by mail.
No, do it now. I will receive yours. Okay.
I sent it to you by mail.
Good. Yeah.
And Professor,
Not with the age, right? With the car
Yeah,
car
with the
table.
car.
Okay,
Send
great.
it to you by mail.
yeah, and Professor, I do the decision tree by the Python package sklearn, and I still use package to draw the picture. Is it okay?
How do you know? How do you know that package?
Yeah, I set
Use
I set
information
it to
gain
use
the way that we did.
I set
If you know for sure, then
yeah,
fine.
I'm sure. I set it to use information gain.
Oh, it has some options to
Yeah.
generate?
It's
Okay.
like control.
Yeah, that's fine.
Yeah, and the picture I drew still use package to just map the data to picture.
If you like, yeah, that's fine. But it's not really great help back to you. But still, I mean, for this course, it's fine. Yeah.
But
Right.
I know the reason. I know.
Yeah, as far as you know how the package is running inside, then I think why not? Any other issue about homework assignments? What about
Oh, yeah, no, I have the same issue as him. The proposal, as maybe.
proposal? Okay, hold on. So group project. Okay, so group projects. So read the group project very carefully, and I set the time, the deadline that you need to write up your group project, and also the time for you to make presentation. Your presentation can be done here physically if you come. Or if you cannot, then thing is this. I do not want part of a team come and part of a team, the same team not come. Okay? It should be done all or nothing. If the team comes here, then all team members should be here so that contribute to the presentation, not separately. It should be one project. So if you cannot make the physical presentation here, then you can record on your own among the team and make one presentation and post it maybe YouTube or somewhere else, wherever convenient to you. And they give me a URL. If somebody give me the false URL, then of course it's not really a real presentation, right? There's no way that I can grade. If there's something that I cannot grade, then I cannot give you points, credits, which means you will receive 0 points for the portion of the presentation. Okay? Back to Johnny.
Yeah, so now I was actually talking about when you graded the assignments. The proposal, I sent you it looked like a blank file. So you made a comment.
Oh, yeah, that's what, yeah.
But I emailed you the same day. I emailed you.
Yeah.
Before the deadline and everything.
Can you tell to everybody here about your proposal? Tell us. What was your proposal? What are you going to do?
Well, we're going to talk about data breaches and specific. We each picked a different kind of data breach, whether it's sensitive data, corporate account takeovers. We have 4 different. That one. We have 4 different.
So you and Ellen same.
Yeah, Keith and.
Oh, you're the same, and Evan, you have the same issue about different team members.
What?
No, your proposal.
We're talking about the proposal.
That was homework 3, homework 2.
Oh, okay.
I sent you a local link to the hard drive instead of.
So you don't have that proposal submission issue.
No.
Okay, good. Okay. So what do you expect from your proposal? What would be the final deliverables?
An answer whether or not the proposal is like that increase.
For example, is it classification or is it generating association rules or what? Is it constructing a decision tree or something like that?
It was.
You can answer the question.
You do not have? Just run?
Still working.
Well, you need to have a goal, right? Goal to achieve. Whether your team reach the goal or not will be different issue, right? Sometimes you cannot because many reasons, right? If you were so ambitious, yeah.
We had the goal, but we don't know how to achieve that goal.
Sorry, we picked the first option, the one that you put in the syllabus says automatic data collection and cleaning.
Okay.
So we group them. That's where we're going to start, and then we're going to.
So what was my comments? Oh, yours was not delivered
Yeah,
to me. Okay.
exactly.
For example, then the cleaning data sets to get ready for data mining. Is it the cleaning process is your proposal or
Well, yeah,
any additional?
In the syllabus it says automatic data collection and cleaning.
Okay.
And programmer required to collect data from online.
Okay, that's it.
Yeah. So.
Okay. Well, that is part of data mining process. But I wish you could have a little more jump in the real mining process. Right now, yours is a pre-processing. You know what I mean? A little bit of a pre-processing. So if you go a little further, for example, some of the techniques that we are going to cover today, make it some distance, using distance functions to produce a table, so that the table is not the table with the raw data, but the table contains distance between columns and rows, so that additional data mining process may use the table of distance, which is also very, very useful.
Professor, what did you think about our project? Our project proposal?
Your proposal is yours. Why you are asking me?
No, your point of view.
So what do you have in your mind?
Huh?
What do you have in your mind?
I know it's good, but I'm asking you because you're going to be the one who's going to grade it.
Right. Did you already submit it, or
Yeah.
then what did I say to your proposal?
I think you said it was okay.
Yeah.
Okay, then it means okay, right?
I mean, we wanted more.
Can you explain a little more for me to recall, and so that we all can think together?
So our project is, so we went to a social work agency here in New York.
Oh yeah. Okay. So did you? So if you
We got the real data.
you will get the data, real data, right?
Yeah, we have the real data. We're gonna do the cleaning with the Weka.
Okay.
Cleaning of the data.
Oh yeah, Weka. Yeah, I
We're gonna
remember.
go SPSS for statistics, and we're gonna do the same thing. We're gonna do it with the R and Python, and then check
Oh, there's a real data mining.
Yeah.
Then you don't have to do all of those. I mean, from SPSS or Weka or all. Use one, okay? One is enough. All may be the best, but if you are not good at scripting, then you may simply use the package or Weka, whatever.
But
Yeah.
for this type of data set, can we use correlation or regression?
I didn't see it, the data, sample data at all.
Oh, okay.
How do I know it?
Yeah,
I'm curious, yeah, data sets that you might have. What?
In general, medical databases.
Right.
Like,
How do you know? Yeah.
it's up to us to choose.
Exactly. Yeah. And then don't forget, finally, if it is the data mining, you need to put interpretation, not just saying, "Oh, this is the data that we
Yeah.
finally achieved." Then, what does it mean to you, to me? You have to describe what it means.
Our final product of this project is a program that's gonna take whatever they do intakes in this company. The patient came, they take his age, all the information, they do psychosocial. This
That's
person.
fine, yeah.
Depending on this information, they're gonna run our program and they're gonna see what's the degree of depression of this person, and they're gonna be able to classify him because there is 4 classifications, and they're gonna be able to send him in which.
What are those 4 classifications?
We did this 4 classification. It's like a scale for the depression.
Okay, so those are 4 levels of classification. We call here data label. Okay, label of a patient, for example.
Exactly, yeah.
Do you know of those 4, whatever the terminologies they are using for those 4 data labels or classifications? Do you know?
For this,
Yeah.
we're doing a scale like from 0 to 25.
Oh, just a scale?
Depression, yeah.
Depression
And
level.
depending on this,
Is it by number?
say again?
Is it in number?
Yeah, in number.
So
Number.
level 1, 2, 3, 4, something like that?
Exactly.
Okay.
Exactly. And from this, they know in which department they can send the patient. Okay?
I got you, yeah.
Yeah.
That's very, very interesting and useful data sets and also real. So that is very good. By the way, how many, what is the size of the data that you would
The
receive?
data set
I think it's 600
600 gig?
transactions.
Oh, 600 transactions.
Yeah.
Are those all sample transactions, all right?
Exactly.
And those are all true transaction, right? True, real person, and attach the labels by professionals' decisions, right?
Yeah.
That's a good training set. Little bit of such things will be covered today's class. So I think this help you also much. Let's try to do this. Okay, from classification to clustering using time series data. By the way, this week and next week we'll do, I would say this is tech nights, which means no additional concepts to learn, but exercise, real exercise. We start with
P90X?
Exercise?
Yeah, both
we have 2 similar guys sitting, one left and one right, and and they are communicating and they are harmonizing, and they're using the same language.
English, yeah.
No, that's not what I'm saying. Yeah, of course, English. Okay, so motivating examples. For example, given time series data, the definition of time series data introduced the last class, right? What is the time series data? How do you know this is time series data and which is not just general data? Why you say that is a time series data? William, I know you missed the last class, so, and also I know you watched my lecture video. So what is time series data?
Of course. What
Yeah.
are time sensitive data?
Time series data.
Okay, I like to use Wi-Fi.
Request my.
Good.
Okay, yeah.
Define.
Define, okay, okay, giant. Okay, goddamn, you're useless. Alright,
Oh, shit.
According to Wikipedia, a time series is a series of data.
thank you, David.
Okay, David. Okay, Dave. See, David is your.
I
It's not-
just Googled time series data.
Okay.
He's your lifeline.
Yeah, that was my last.
That was your life.
Yeah. Okay, thank you for enough, friend. I was going to ask the audience.
Yeah. You're advocate. Okay.
We are the audience.
Yeah.
Well, it's data that's taken as successively equally spaced points in time.
Okay. So time series data is a series of data over the course of time, right? So time needs to be involved. Time is not necessarily the physical time. For example, December the 1st, 12 o'clock, or whatever the time tick. Okay, it could be a series of numbers, 1, 2, 3, 4, 5. That is fine. There's a sequence along the timeline.
So it's something that's organized.
Some organized data, right? So there's a special meanings. One data ahead or behind. It's not just a data sets, but a data sequence. So how do you know time series data are similar or dissimilar? If you have a series of data. Let me see if I have an example of data. I forgot to enter here. So it should be like this. So are they similar? Someone may say, oh, they are similar. Someone may say, no, they are not, right? In what way you think they are similar? See, data points 1 to 500, right? Along the timeline. See here, this is the time. We have 500 data points. Similarly, we have 500 data points, right? And price, somehow like this, right? Are they similar? Someone may say it's similar, right? In what way do you think it is similar? So you need to have an answer to such questions. Okay? So we need to generate 3 time series data and see how much we can do for data mining. This is the hands-on exercise for tonight. Okay? So we need to generate not just 3, as many time series as you can. Okay? With some sequence. So ordering is very, very important. Once you have time series data, then we need to discover something from there. So what can you discover? This slide gives you, for example, what can you do with the time series data? First of all, you may estimate seasonal variances. So as an example, here, for the sales during October, November, December are 80% and 120%, 140% of average monthly sales for the whole year, respectively. Then 80, 120, 140 are seasonal index numbers for those months, right? Those are the estimation. Okay? And also you might have some actual data that you made last year or previous. So you have a past data. That is the real data. We call that truth data, true data. Data of truth. So we rely on that true data. And then for estimation, then you might make some projection for next year, for example, okay? Next year, October, November, and December. So that we can see your how your projection is reasonable. Okay, by looking at the past data. That is part of the discovery from time series data. Okay. Estimation of cyclic variance, estimation of irregular variance. With the systematic analysis of the trend, cyclic, seasonal, or irregular components, it is possible to make long-term or short-term prediction with reasonable quality. So we'll look at those things. Similarity. Normally, in order to show the similarity, in more reasonable, more clearly understandable way, is to give some number. So quantization is very, very important. In other words, if we have some distance function, so according to the function, we can generate similarity. If they have a long distance, then maybe less similar than the short distance, right? If they are not exactly the same, according to our measurement. So measurement needs to be developed. So each area that you are considering, you may have different measurement formula, different distance functions. Distance functions have been delivered to you in many ways throughout this class. One easiest way of distance function is the Euclidean distance function, right? One of the simplest Euclidean distance function is Manhattan distance. City street distance. If you are in one block, the same block, if David in the southwest and William is northeast, what is the distance? Then there's one avenue distance and one street distance, right? That is their distance. If it is not city, then you need to get the distance diagonally, right? See here, this is one block. This is another block. This is another block. And another block.
Okay, so what's your mind?
Okay, this is Herald Square. This is Mercy College. This is Macy's. Is that right? Somewhere here we have Empire State. There. So for example, David standing here and William is standing here along the Fifth Avenue. What is the distance? If it is a city, then distance of one avenue and distance of one street. That is the distance, right? So the length of this and length of that, sum them up. That's the distance. If this is not a city but any shape, then distance could be diagonal. That's the distance, right? There's another distance. David here, the corner on the streets. William is on the 7th floor. What is the distance? If it is a city-like distance, then you need to measure this, add it to the distance of that, and then height from here to the 6th floor. That is the distance. simply linearly add all the distance. That is a Manhattan distance. If it is a Manhattan distance, but just a three-dimensional distance, then what happens? If you make this in another way, it will be like this. Okay, so David is standing here, and William is here, on the 6th floor. So we have floors, right? Behind here, there is a subway, the street, if you remember. So what is the distance in this case? Distance is this. Three-dimensional, right? But anyway, distance function needs to be defined and calculated. One of my suggestions to Johnny and Alan's project, not just a cleaning, but provide some distance matrix. So that is a contribution to data mining. So you'll see why tonight's exercise. Okay. Applications, you know applications for any. I know some use medical, scientific, markets, financial markets. Somebody is doing financial also. So when I read your proposals, part of my appreciation to you is that, our students try to gather the real data, not just the data from the website, but the real data. Like Chris came to me 2 minutes prior to our class and asking about DNS server data, but I do not have, or we may try. Okay, so we'll look at this. All right, so the practice. Generating time series data. There's something that we want to do, okay? So I'm going to explain this code. What code is this? Python. Oh, thank you. Who said that? You know Python now, right? Great. I'm glad that you didn't say, oh, R. This is not R, okay? I explained some here, and also on the bottom. Okay, here. This is more practice. Okay, practice to generating and plots more data. That's what I ask you to do. Okay, so explaining to you. You need to import pandas. Pandas is a very, very useful package when you deal with data sets and analysis of data. There are many, but pandas is one of the useful and only developed data packages. So pandas is an open source of data structures and data analysis tools for Python programming languages. So you need to import that. And another import needs to be done for numpy. Anything about number manipulation in Python, you better import numpy. NumPy is for number Python. Okay, numbers in Python, for example. And all I have some alias, some name for short, PD for pandas. If you don't say any after as and some value, then every time you want to do, then you need to spell out pandas, NumPy. This is just for convenience. If you want to plot, then you better to have math as a mathematics plot library, matplot library, and then there is a module called the PY lab, Python lab, and we call that PLT. As you see here in this example, then we generate two data sets, right? Okay, TS1 and TS2. TS means time series data. That is your variable, TS1 and TS2. You may call different, okay? And then another statements, before we generate time series data, I set the point of x, okay? There is a time, right? Data points. That is used here, that x. The same x used here, and same x used here. So you need to first define. Remember that in mathematics, in typical algebra, then you have independent variable and dependent variable. So x is an independent variable, which means independently it is defined. So x can be generated by np.line space, LIN space. What is a line space? Line space is a function, as you can see here, that takes multiple variables, but first three variables needs to be given, and then the rest you don't need to. If you need to say, then you can have a pair of those values. For example, RET step equals false or true, D type, whatever the data type that you want. If you do not want, you can omit. They're all optional. But start and stop needs to be there. So start point is 0. So x, so independent variable, x starts from 0 to 50. And how many data points? 100 total data points. But you name it in different way. If you do not have 100, see here, first and second, there's a mandatory. And third, if you don't say, then I think the default data points, number of data points is 10, maybe 10. It only generates 10 points, if I remember correctly. Let's look at the first data here, time series data. Time series data is generated by the package PD. What is the package for PD? Pandas, right? Pandas package has a class called series. Okay. If you want to see more example about pandas, I have here a website. So access to website and see how much that you could do further. Not just only series, but maybe more than series. If you see here series, then series can receive a function. What is this function? This function is point 0 for x and cube. Someone still remember this kind of formula, right? So according to this formula, if you enter the value for x from 0 to 50 in 100 points, then for each point you may have the values, which is independent variable. So actually this TS1 and TS2 is a series of data sets according to that x, variable x. Okay. Once you generate TS1 and TS2, I want you to use the function plot. Okay. All right. So if you do plot, then it doesn't do anything yet. You need to show it. Okay. That plotting should be shown by this function, which is from the PLT. PLT is a matplot library. So plot.show, open and close parentheses, then all the descriptions that we defined from here above will be plotted. We have two time series data, and if you see here y lim, y is a limit of y-axis. So limit of y-axis is from -2 to 10, for example. And then we may put some legend. So the first plot is TS1, second plot is TS2, something like that. So what we will do here, okay, this is, oops. This is something that I want you to okay. What I will do is no. Okay. No, not this. Three, two. No, I don't have that. Oh, this is the same one. Okay. What I'm going to do is to start from the scratch. Okay? So, you need to first to import. Are you guys following? Or you need to practice. You guys have Paizo?
Maybe.
And pandas as PD, and import another which is numpy as np, import mat plot lib and py library as plot. And then we can generate x equals numpy and line space. I want to make it to generate starting from 0 to 100, for example, and generates 200 data sets. So which means total 200 data sets, but the range is from 0 to 100. And then first TS1, first time series data is, I'm going to bring this to my so that you can see my Panda PD for Panda series, and whatever the formula. If you want to make a quadratic or polynomial or linear, whichever convenient to you, or sine curve. For example, np dot sine curve x over 1.5. I'm doing this the formula as shown in your slide. And then first time series data needs to be plot. Before we do, let's do this. I want to print TS1. Okay. What I want to do is I'm going to highlight all and Alt enter, then it py left. So what happens? Line 6. PD series 3.1. name error, NO. Oh, should be NP, not NO. Okay, save it. Oops. No, I'm not going to save it, but well, let's save it. Why not? I want to save it to my course folder. I want to say generate time series. Okay, then I'm going to run it. Here you go. So we have data sets generated. It's not really arbitrarily generated, but it is. See, we have 200 data points. So we have 200 data points from 0. And according to this formula, more precisely, if you make, for example, make it simple, say 2 times 2x plus 1.2. Okay, and then run it. I want to make this print ts2, save it, and run it. Then I have data. This is a linear data sets. If I enter 0 for x value here, then the first value for this formula is 1.2. If I enter, what's the next value? I think 0.5. If I put here 0.5, then that is generated. 1.5. 1 or 0.5. 0.5. Whatever that, right? So that is generated. And then we want to plot it. So how can you plot? So to plot, ts1.plot, and then you can say plt.ylim, limit, I would say -5 to say 15. Okay, and then you can do plt2.show, then it'll be shown. Save it and run. Then it appears in another, right? It is generated that way. So one single data plotting. But if you want to plot ts2.plot, and save it, then you can see this. But this is high slope, right? So we don't see it very well. So what I'm going to do is, instead of 2 times x, I want to make it 0.04 so that it increases slowly, which means you can see those two data, time series data. See here, time points 0 to 50, 100, 120, and 200, right? But if you change this to 300, then you have more data points. See here, more data points, from 0 to 300 data points. Okay. Right now, you do not have the legend, so you do not know which one is what. So if we want to make it, then plt dot legend in an array, or simply list in Python terminologies. Okay, and then oops. Invalid syntax. Oh, there's no. I need to have a close. Okay. That plot is not defined. Name plot. Oh, not plot. PLT. So you can see like this. So as you see, I don't know what color is this. This is red. Okay, red sine curve. So red is a sine curve. Or you can say, as shown in the slide, you can say TS1. But actually TS1 is the variable that we used here. But you can rename it as you wish. Okay. For example, TS2, then a linear line, so that green is a linear line. So according to this legend, you can make more time series data. Okay? What I want you to do, I want you to, as shown here in the low right corner, see here I said the TS3, TS4, TS5. I want you to create more. TS3 for similar sine equation, sine curve, similar to TS1. TS4, I would like you to do to generate cosine curve. TS5, a quadratic equation. Those who want to read more about Panda, you can read the Panda website there. Okay, so let's do it.
Basically copy what he's got on the presentation. You just keep the plus. You just give the plus. Ozzy didn't yell it.
No?
Generating data points is the first step that we can do more about data mining from time series data. Okay. Of course, your data is not time series data.
Can do. We can find the function and then put it on the graph.
The thing is this: time of the depression level over the course of time important or not? That is the issue. If it's
No. The thing
If
is,
it's not, then time series data is not really important. For example, depressed level given patient or among the patient. The depression level of one patient related to depression level of another patient. There's no correlation at all, right?
no, it's not.
Right. So it's not, the sequence is not really
Yeah.
the issue.
They've been running this data all over the years, and they have all of this, and they want us to mine the data in order to find patterns and then generate rules
Right.
that can help them.
If the following is their interest, then there's a time series data. The following is this. They have one separate table for each individual patient, so that along the course of time, they have historical data. So by knowing, for example, this patient has some seasonal or periodical depression symptoms, and if that is the case, then definitely that is
For ours is not the case. But this will be very interesting because it's going to be related to the time, and then you can generate time series data.
No, they don't.
I'm level They're level 1 and level 1.2. So anybody has 5 of those already? Dave, do you have? Look at something. I thought I was doing something else, but you were following well.
I am doing what else.
Probably Evan has 2 processes. So one following me, another process doing something else.
I have an idea. I can't sit and do one thing at a time. I have to be playing.
Exactly, that's what I'm describing.
It annoys
So
me.
sometimes the class is too slow to you, right?
Sometimes, and other times I am lost.
So you want to use the 5 CQs that you have all together. Generate more and more. Sine curve, cosine curve, and more. As I asked you to do that. Python? Do you have Python?
Yeah.
Yeah. Yeah, I know. Yeah. Okay. With all of sine and cosine right. Okay, let's try. It's not really clear to me. I mean, I cannot point my, okay, here. All right. I'm going to TS3. What we need to do is a similar equation. So what I would like to do, I'm going to copy and paste and change a little bit. What do you want to change? The magnitude, or yeah, we can change something. Instead of 3.1, I can say 2.5, and then instead of x over 1.5, I want to do x over 1.3, and I want to add finally 2.7. How about that? Okay, so I want to do ts3.plot, and then I want to have here another legend called sim sine curve, means similar. And then I can run it. Where is it? Oh, good series. Okay, I have here. Wow, looks good, right? Let's do one more. The other one is cosine equation. So I'm going to use TS4, same one, but instead of sine, I want to make cosine. How about that? See what happens. And then I want to make this also TS4. And here, cosine curve. Save it and run. Wow, too busy. So what I will do, I want to change this to 200, because so many data. I will do 100, okay? 100 data sets. That may be a little better. Like this. So in sine and cosine here, there's a back-to-back, right? Because sine and cosine in plotting, and sine and cosine in value-wise, they are similar, but only shifted one or the other, right? You know that, right? How much it is shifted? If you want to see, for example, 10, only 10 data points, see what happens. Oh, this doesn't look good. I want to make this also. Looks like this. Sine curve is blue. Sine curve is blue. Cosine curve is what is this? This is not green, but like it's. What is the color of this?
Blue.
This is blue.
Light blue.
Light blue? Yeah, whatever that. So this and that. There's some shift, right? We call that phase shift. That's what it is. Okay? I want this make 100 and 100 and y limit, and I want to do PLT x lim. So x lim is 0 from 0 to 200. See what happens. Oh, there's no x lim. No, plot. Thank you. PLT. Yeah, I got it. So this is half. So what happens here is I will not do, for example, 50 only. So we generate 100 data points, but I want to plot only 50 so that we can see in this way, a little clear. So one more, the last. So TS5 equals what it says is quadratic equation, quadratic. So PD, give me one quadratic equation.
Yeah. There's a square root in there, I know that.
Okay, now David. So what is a quadratic equation according to
I never
Wikipedia?
took calculus, so I could look it up online, but I got far without calculus, and I plan to continue that way.
I'm pretty sure that was algebra.
Yeah, I haven't taken that since high school.
Yeah, me neither.
I'm pretty sure it's
Oh, that's a massive banner from Wikipedia.
I think Caleb, you might know. What is a quadratic equation?
something divided by something.
Oh, a squared times b squared plus c squared.
Exactly. Yeah. Ax squared plus bx squared plus c.
Oh,
Just-
no, that's
That's
not.
ax squared plus bx plus c equals 0.
Yeah.
I was thinking a squared plus b squared plus
So,
c squared.
so we need to put some number. So what I'll do is x square means double
Quadratic equation?
double star, and then I will do 2x and then minus 1. Let's just generate arbitrarily. Oh, and then I need to do here TS5 dot plot. I want to put here the legend. Quadratic. Save it and run. Wait a minute. Okay. This is a quadratic. Anybody knows how we can make this fat quadratic? Fat.
But
Yeah. Quadratic. That quadratic is a slim line, right?
yeah, you're gonna add
So
the constant. Either of using -1, you're gonna do plus 50.
You know what? What I will do is I'm going to put here very small number. Okay. See what happens. If you can see a little fat, oh, this is a little fat, right? So if I want to do it's real and put here also not that, but 1 point, 0 point, whatever that. This is very fat, very slow. I want to make it a little better. This, maybe this. Still, Still very fat. What's the factor? Why that? Is this a factor? It grows a little bit. So I want to make this simply into. Oh yeah. So that's a big factor. If I can make this, for example, negative from negative 10 and y from negative 15, the limit of the axis. So that you can see a little. So this quadratic function's coming from somewhere here. Doesn't look good. It's negative 1. If I want to make this simply positive 1, and then this is not good. So simply 0. Negative 5 is good. Okay, so reasonably, this is reasonably good. Right? Quadratic. So we practiced a lot of generating time series data. So what we will do next, before this is done, computing distance. We want to make some distance using the distance function. As I said, if you want to make distance function along diagonal line, there is a Euclidean distance. Distance function that we are talking about here is not a Manhattan distance. If you want to make Manhattan distance function, what do you need to do? I'm going to ask you. Evan, I know you have 3 brain processes.
Sure.
I wanted to use the last brain CPU to think about Manhattan distance function formula by looking at this. This is Euclidean distance. If you have A and B, what is the distance? Say it is def in Python. You can say man, her, make it short. Manhattan distance and given 2 data points, A and B, colon, and then you can return. You don't need to do square root. This Euclidean distance is that A minus B square and square root. This is Euclidean distance. Euclidean distance. Euclidean distance. If it is a Manhattan distance, you simply say A minus B and absolute value.
What?
Which is
Absolute value.
Which is the same.
Which is the same in if it is hold on. If it is a point only, but if you want to point, for example, A is nothing but x1, y1, z1, 3-dimensional, then they are not the same. if you have only one dimension, x is x1, and y is, b is x2, then they are the same. Only if single dimension, but 2 dimension, 3 dimension, 4 dimension. Even though 3 or 4 dimensions in Manhattan distance, simply subtraction and add them. Here, x1 minus x2 squared plus y1 minus y2 squared plus. Exactly. So in this case, I think absolute value and a minus b. Okay? This is for Manhattan distance. But that's not what we want to do. We want to do this Euclidean distance. So, what I wanted to do is to generate that. Add that to your program. Okay. Yep. Okay, I'm going to close this. And what do you need to do? You need to create the function here, right? So DEF Euclidean distance given A and B.
Return.
Then, I'm sorry?
Return.
Yeah, return. Thank you.
Square sum.
Square root. Oh, you have good memory. Square means 2 stars and 2. And then first close the parenthesis is to close for some function, and then one more close parenthesis that is closing square root. Okay? And what I want to do at the plot, after plotting, I want to print Euclid distance of time series 1 and which ones are similar? 1 and let's try to do 1 and 2. They are not similar, right? They are quite different. We have some bugs. Virus? Bug?
I turned it on. Yo, I see it. Okay. Good, you got it.
Wow.
That was skill. Like, I am impressed. Like,
We have a good debugger.
yeah.
Ellen, you have talent in debugging. Okay. Where are we? Okay, TS1 and TS2. And one more close. Right? Okay. I want to save this and see what happens. Execute. Look at this. I do not have any answer. Why? Because I need to this plotting first. When I close this plotting, then I can see the distance here. Error. What is the error? Debugger.
You need to import,
Alan,
square.
debugger, can you debug this?
You got what?
So the way that you can debug in Python, for the Python coding in Paizo, you have to read this red.
Did you define that?
Hold on. I'm going to explain this. This is intentional error.
What do you mean this is intentional error? There is no such thing.
It's a line 29. You need to find out line, somewhere here line. Then you need to see here line 29. And this guy calls another function, then there is a line 6. So line 6 has an error. Where is it? Line 6 here. So somewhere here, there is an error. The error message here, name error, name square root is not defined.
Put the same thing I did.
Yeah, sometimes it doesn't. If you have that, then square root, SQRT, is a function from which packages? NumPy, yeah. So what should I do? NumPy or NP? NP. Run one more time. I'm going to close this. Watch. What is the distance between TS1 and TS2? 2.5, right? What I'm going to do is I'm going to comment this out so that I need space. So while I have that, watch this. Oh, still too much. So I'm going to comment all out. I'm not sure, legend effect. Maybe. Let's try. Legend will be okay if I don't do anything still. Oh, this is very clever, right? In legend, I put all 5 labels. But because I have only 2 data to plot, it eliminates the rest, but only for those data, time series data, right? Sine curve and linear. Okay, what I'm trying to discuss with you, how come we have this number?
We have this number because they're linear. If there wasn't linear...
No, how come this guy make distance between sine curve and linear?
I've chosen 2 numbers. I'm calculating the distance between the 2 functions.
Probably you understood, huh?
I was doing that when I was a child.
Oh, same as me. Okay, what it does, because I cannot paint here. I don't think I can paint, right? Here. Oh, another way that I can paint. Well, I cannot paint. So what it does is that for each point, see here 0, and then the next point is 1, right? So 1, then that is given by increasing x points, then we have 2 y values from 2 time series data functions, right? So we have this value and that value, this and that, so that we have distance. For each single data points, we have distance, one from another. That is the reason that we have that. Okay? Let's try to do a little more. I want to open, time series 3 is similar to time series 1, right? So I'm going to open time series 3. And I'm going to make this. What I'm going to do is that I'm going to put here, say, distance between TS1 and TS2. Okay? I'm going to plot another. And TS2 to TS3 to TS3. Okay. And then I'm going to run. So I have this. If I close this, then you will see those. So that I'm going to do one more time and discuss interpretation. See a distance between TS1 and TS2, which is a sine curve and linear. That's a distance. So sum them up. That is 25.14. And TS2 and TS3. I need to make TS1 and TS3. That is the reason they still have similar distance. Wow, there's a more. Wow, I didn't know that. More distance. Blue and red, so more distance than blue and linear. Oh, strange. So let's make it similar. So 1.5, and this is 3.1. 3.1, and only I want to make this 3.6. They are very similar, right? Now, okay. See here. I want to bring this. Blue and red, they are very similar. So distance between blue and red, there is a 1.0. But blue and green, 25. It's a big difference, right? So, but anyway, how so what I ask you to do here, I ask you to do some other time series data, but we did that already, so you don't need to do. Okay? Any questions so far?
Just move the graph over a little bit, like to the right. Make sure left, right.
You mean shift those two time series data? Is that what you're saying?
That's like the actual window to the right, so I know it's the code.
Oh, you want to see the code?
Yeah, make sure it's right.
What we will do, instead of taking break, this is already after 8 o'clock, so we will continue to do, and instead of breaking, I will stop only 10 minutes only.
No. Peter, come on.
Yeah, we'll stop only. Not right now.
You have 20 minutes.
Yeah, usually, if I give you 15-minute break, usually students take a 25-minute break. So, okay, I'll stop 25 minutes only, so that you can avoid some of the heavy rains tonight. I'm sorry?
It's not that, it's that the cafeteria is incredibly slow to get food, like it takes 25
Oh,
minutes.
is that right?
to get food. Yeah.
The new people, they don't know.
They don't know what they're doing at all. It's really bad.
Every time they have new people, right?
Well, even the old people don't know what they're doing.
Old people don't do work. New people don't know how to work.
So that everybody should be
Okay. So because of raining, I think we better continue to work. Okay. What is next? All right. Dynamic time warping. Dynamic time warping. So if you want to see dynamic time warping, I want you to visit that Wikipedia, dynamic time warping, and then share your understanding and discuss about how to implement. Think about how we can implement. What happens here is that so far, the data that we generated in Python, they're all lined up, right? If X value, then they are lined up. So very easy to compare. For example, for the X value 5, then we clearly see the value for the time series 1 and value for time series 2, right? So that we can definitely subtract one from another and sum them up for entire distance. But what if it is not? For example, this guy has different time scale. For example, this guy has, listen. We have two time series data. First time series data, this is for a month. This is weekly data. Okay. Weekly data, therefore there is no data for weekend. No data for weekend. Another data is a daily data, so that it counts all the data. If we compare those two time series data, then for the weekend data over one time series data, there is no values clearly matched with from the other time series data, right? That may happen. I mean, Saturday and Sunday data appear in one time series data, but not another time series data. So if we compare the data according to time, absolute time itself, then our computation is not going through, right? So in order to avoid that, we need to warp the time a little bit. So as you can see here in this picture, this guy matched with that guy, and another guy here, this matches right another guy. So what happens here is that we do not compare the data, every single data points. Rather, for example, if we have this kind of data, and at the same time, if we have another data like this, then I want to compare this with that, and I want to compare this with the other, right? Only the similar way that it does. So I want to compare with this and that, and compare with that, and compare with this. That's a time warping. So more intelligent computation of time warping. This is the points. So I'm going to give you time to take a look at that website. 5 minutes. So visit that website and get some understanding. This is a website that I asked you to look at. And if you see, then there's some implementation algorithms. So we're going to use this implementation algorithm. This, for example. This is written in C, but we need to convert that to Python, which is on your slide. So I wanted to read this. That dynamic time warping improves the time series analysis significantly. So as you can see there, it's called the DTW. It's an algorithm for measuring similarity between two temporal sequences which may vary in speed. Okay. So it is not, time points are not really perfectly lined up. So that we only see the shape only. In other words, if we have data, I want to go back here. Remember that earlier? This kind of data. How can we compare these two data? But we will see, oh, this part is similar, right? This part is similar to that. And somehow it's similar. And somehow this much is similar. So, can we compare only this with that? Then they are really similar. Okay? So that this guy compare with that, rather than this guy compare with somewhere here, the beginning data points. That is what this guy explains. So I want you to take a look at that algorithm. So is there any volunteer to explain that algorithm? David, can you explain?
I don't have the energy to do a trace right now. I mean, it looks like a couple of for loops. I'm assuming if 1 is not equal to n, I don't know what DTW is to L, this is time warping, I sub 0, not equal to infinity, and there's another iterative for loop. Yeah, I can't process this right now, I'm just too exhausted.
You said not equal to 1?
Isn't that what that means?
That algorithm, yeah, it's like, for example, first for loop is I increase from 1 to n.
What does the colon mean though? In this.
That's what I'm saying. Yeah. Here in this language, I starts from 1 to n.
Oh, okay.
That's for loop. Okay.
All right.
So 1 to n means, for example, that function. Look at the first line, dtw distance. There's two input variables, s and t. Yeah, two lists, s and t. S, the size of s is n, so 1 to n, right? Size of t is 1 to m. So two different size data. So that is useful for time warping. It's not homogeneously depicted over the same time span, okay? Different time span. So 1 to n and 1 to m now. And the DTW, there is an array, so n to m, n to m. Two-dimensional, right? So DTW is two-dimensional. Given data, one single dimension data, but it produces double dimensions. So I'm going to explain that for a minute here. Okay? So for example, if I have S value, time series S, so I have data values. Data here. And I have T. So different sets of data from here to there. So the result is simply a table, two-dimensional array, or you can say table. So this guy is starting from 1 to n. This is index. Again here 1 to m. So not necessarily the size of this table is a square but rectangle. And then the distance between this and that will appear here. There's the distance. So this guy compute the distance for this time points, compute the distance all the way to the other. And for next data points of t, needs to compare every single data points in S so that you can have some values as distance. So you can fill all the data there. That's what this guy is trying to do. So initially, this is initialization. Initially, DTW I say I comma 0 and DTW comma and 0 comma I. So initially what it does is that initially Yeah. What this guy is that initially everything, the distance is all maximum. Okay, infinity. All infinity. And then we override with the value that we know for sure that is the distance. Then we override it, and finally we do something else. Okay? So this is the initialization from here there. They're all maximum numbers. And then here, 2 for loops, inner loops, outer loop and inner loop. So for each data points from S, we want to consider the data points in T. There's 2 double loops. And then we calculate the distance. This is simply distance, any distance. You can put here Euclidean distance or some other distance, okay? So you calculate the cost of that distance. Every single data point, each pair of data points. But DTW contains only the minimum of neighborhood.
Why?
For example, why?
Yeah.
Maximum is infinite as we initialize, right? If we put maximum, then there's maximum, infinite, right?
We just want the distance, so why just put the cost? We just want to fill up the table.
No, the thing is this. Hold on. What happens here is that's a very good question. Not only this guy wants to compare with that also. My cost is only the cost, this. This is my cost. Okay? Then my time alignment, those 2 time series data are not aligned over the course of time, so that I can say, oh, I may compare with the one before, right? So I compare with the one before, and minimum of this, not the maximum. If it is maximum, then that is infinite anyway, right? So for safety, okay, we don't generate entire minimum distance. We keep this distance, but still, this may be compared with the others, every single point. So when I compare with this, then I still want to compare this with that. I take that into consideration.
If it's equal 0, that means it's a matching point. It's a line point. If the distance to the other point equals 0, that means it's a line point.
So here, my compute is I and J, but I want to see J with the 1 before, and I with the 1 before of J, and both are 1 previous. So this guy trying to take all possible consideration. The thing is this is not really aligned the data points. Align the data points. So it could be 1 before, it could be 1 after. We do not know, right? But by having all the data, possible data points, and then if you consider possibly 1 before, then we consider all entire, right? If I consider 1 before, then what about 1 after? Then my next neighbor will consider 1 before, which is me, right? So which means entire throughout all data points, we consider all neighborhoods and myself.
So that for every point of the graph, you have the distance to every other point.
Every other point, that is the same effects.
Okay.
Right. So this is a code. this is very the same as you understand. Oops. See here, by taking, where is my, okay, here, by taking two time series, S1 and S2, initially starting from empty, I enter maximum number, infinity, so that all the data has initially infinite number. So this is from here there. This is my two loops, outer and inner loops. So that I have for each data points of S1 compared with each data points of S2. Initially I compute distance, and then that is added with all neighbor, 3 points neighbor. Okay, and finally we need to do square root of those. Okay. So I want you to add this to your program and practice. See the difference between Euclidean distance and this DTW distance. Okay. The big difference between DTW distance and Euclidean distance is that if you use Euclidean distance, then two data points needs to be exactly lined up. But if you use any given data, size are not necessarily the same, because some shapes, think about this, stock price. If you plot the stock price, one item, it increase, decrease very slowly. Another item quickly, but the shape eventually the similar shape. How can you make them similar? How can you see in computation they are really similar? But to your eyes, they are similar. But if you compare that any programming distance function, then no way that you can see the similarity, because those two data are not lined up. Therefore, this algorithm, DTW algorithm, is very, very significant. That's what we want to practice. That's the code, of course. So code so we have depth Euclid distance here, and then we can do another definition, depth DTW distance, and S1 and S2, comma, and then initially DTW equals empty. No, it is and then for loop I in range length of S1. This is a for loop in Python. This is the same as for I equals 1 to whatever the size of first time series data. To make it possible here, I want to have one more parenthesis, right? Measure the length of the first data points. And I want to make it range, which means range means by default, if I have, for example, range thing here, here's this. If you want to do range 9, what happens? Range 9, okay. Print range 9. I don't see any. But if I do for I in range 9, and if I want to do print I, then it prints from 0 to 8. If I put here 9, then it's, I want to generate 9 numbers, 9 iteration, but because I didn't do anything here, it starts from 0. But similar thing, if I do for I in range, if I want to say 2 to 9, then it starts from 2. If I don't say anything, just 9, then by default it starts from 0. If I say 2 to 9, then starts from 2 to 9, but the last number should not be included. Okay? That's what we have here. Not included. Last number is not included. Similarly, for I in range 2 to 9, but every other number by increasing 2. If I do print I, then what do you expect? Range 2, 9, 2. Can anyone say? Two, 4, 6, 8, right? All right, that's the range. So there's a for loop. I wanna iterate for the size. Iterate the size of the data points in time series data as 1. That's what we want to do. And then I'm going to put DTW -1, I -1, no, comma, -1, float, infinite. Okay, I want to do this for J also. So exact same one for J. And here -1, -1, and I don't need to change it to J. Simply I. Okay. So I make that. And then finally, those 2 points, -1 and -1, also 0. So for example, for I in yeah, S1 and inner loop J in range len S2 dist equals S1 I minus S2 I 2. And then we simply, let's try to print distance, see what happens. And then we simply run dtw distance ts1 and ts2 and save it, run it, so that as before we have this. These are the distance that calculated by this function. So for I, for j, for example, if you want to do, then you can say dist of S1 I and S2 I okay, and save it and execute. I'm going to close the picture chart. So many, right? So as you can see here, the computation time, CPU time is very, very small, but I/O to print, to read, time for read and time for printing, it takes so long, right? So instead of that, if I do here, you see. Okay, here, I'm not going to do this. but simply not the value, but index I and j. Okay, index only. See what happens. Do you see that each every single comparison? 1 to 1, from 1 to. Take 1 from, see here, take 1 from 1 time series and compare with each every 100 data points. Take 56, 100, 59, 100, 61, 100. Okay? I know this. Because of this, there is another computation to speed up this comparison. That is also developed. That is in the website that I pointed you. And the next the algorithm is for the improvement from there. So this gives you a little bit of idea of dynamic time warping comparison. Of course, see here, instead of this, you need to do add them all, and then finally you have one number of the distance. Right? Finally, it will return one number. But I want you to do this. But I'm going to stop here. Any question?
Sorry, can you scroll down in the code again? Sorry.
I'm sorry?
Scroll down in the code. What about
Yeah, I did only simply this. I called that function with the 2 time series data. You can change it, TS1 to TS3, or whatever combination.